Welcome back. In this first lecture, we will discuss the basic facts about GMAT and its quantitative mathematical section. I will present to you the two fundamental types of GMAT questions and share with you the crucial strategies which can be applied to find the correct answer. Let us start with the basic question why GMAT has a quantitative section at all. As you know, GMAT is a standardized entry exam into MBA programs. Now, you don't need to be a mathematician in order to be successful in business. But business administration certainly requires skills and knowledge of percentages, interest rates, probabilities and statistics, numbers and basic algebraic equations. GMAT quantitative section is designed to check your skills in precisely this area. Now, what is the structure of GMAT mathematical section? You will have 75 minutes in order to answer 37 questions. There will be precisely two types of questions. Roughly half of the questions will be problem-solving questions. Another half are the data sufficiency questions. Let us now discuss the structure of each of these two question types and look at some basic examples. So what are the problem-solving questions? These are the ordinary multiple choice questions. For example, Michelle is 10 years younger than Sarah. 10 years ago, Michelle was just half as old as Sarah. How old is Michelle now? The GMAT problem-solving questions have 5 choices for the correct answer. Here, the correct answer is B, and I will teach you the logic behind it. The second type of questions are the data sufficiency questions. Here, you are not asked to find the answer. Rather, you need to decide if the information available suffices to find an answer in principle. Let me repeat. It's about whether the data suffices to find an answer in principle. Let us look at an example. You have to decide if x equals y. You have two equations, two algebraic equations which you can use. All data sufficiency questions have the same 5 choices. The first choice is that the statement 1 alone is sufficient, but the statement 2 alone is not sufficient to decide if x equals y. The choice B is the same as choice A with 1 and 2 interchanged. The choice C is that the statements 1 and 2 together are sufficient, but not separately. The choice D is that each statement alone suffices to decide if x equals y, and the last choice is that neither of the two statements suffices. Let us repeat what each choice means once again. Choice A is that the statement 1 alone is sufficient, but the statement 2 alone is not sufficient to answer if x equals y. Choice B is that the statement 2 alone is sufficient, but the statement 1 alone is not. Choice C is that the statements 1 and 2 together are sufficient, but not separately. Choice D is that each statement alone is sufficient. And choice E is that 1 and 2 together are not sufficient to decide if x equals y. By the way, the correct answer in this case is C. You need both equations, and you will learn during the course why. Let me emphasize, it is irrelevant if x equals y or not. You just need to decide if you have sufficient information available to answer yes or no. Let us look at another example. You have to decide if x equals 7. Again, you're given two statements which you can use. Again, it is not about an actual answer. Rather, it's about whether there is sufficient information available to decide. In this case, each statement alone is sufficient, and the correct answer is D, even though for both statements x will not equal to 7. Now, it is important Do not confuse a no answer, x equal to 7, to the actual problem with a not sufficient answer to the sufficiency question. Let us now talk about strategies. The best strategy is to know mathematics. However, there are 3 survival strategies. The first strategy is to plug in examples. The second is to solve the problem backwards. And the third one is to eliminate obviously wrong answers. Let us discuss each of the 3 strategies now. We illustrate the first strategy of plugging in examples with the following problem-solving question. The salary of Eric and the salary of Anthony are in the ratio 3:2. If Eric's salary is doubled, while Anthony's salary is halved, some of both salaries will change, and you will have 5 choices for a possible outcome. Now it takes too long to solve the problem algebraically. Instead, we shall plug in example values. Let us assume that Eric's salary is $3,000. Anthony's salary is $2,000. This gives the required ratio of 3:2, and the sum of both salaries is $5,000. Now Eric's salary is doubled to $6,000. Anthony's salary is halved to $1,000, and now the sum is $7,000. In order to see what the overall change has been, we just need to divide 7,000 by 5,000. This gives 1.4, so the increase of the overall sum of salaries is 40%. This corresponds to the correct answer, B. Let us look at the second strategy, solving the problem backwards. The principle is as follows. It is easier to check that an answer is correct than actually finding that answer. Let's look at a question. What is the solution of an algebraic equation 9 to square root of x minus 3 equals 2 times 3 to the square root of x? As in any problem-solving question, you are given 5 choices of a possible answer. However, it is hard to solve this equation explicitly. It is much easier to check the possible answers. Here, plugging in the first choice already solves the equation, so A is the correct answer. Now the final strategy for this lecture is eliminating obviously wrong answers. You have to eliminate intelligently. Sorry for the double L, it's a misprint. And you should note that elimination of even a single answer is already helpful. And then, in the worst case, you have to random guess the remaining choices, which has a much higher probability of finding the correct choice than if you did not eliminate before. Let's look at an example. What is the non-zero digit of 20 to the power of 121, coming as first from the right? As usual, you have 5 possible choices, and it would be very helpful if we could eliminate at least some of them. Now the last non-zero digit of 20 to the power of 121 is the same as the last digit of 2 to the power of 121. Since the 0 in 20 does not impact the non-zero digits. Now 2 is an even number, so its power, in fact any power, is even again. It is divisible by 2. Therefore, the last digit must be even again. So the choices A, C, and E are obviously wrong, and we are left with the 2 options B and D, which are the only even numbers. In fact, in this case, B is the correct one. We conclude the lecture with exercises. You are free to pause the video any time to think for yourself. The first question is a data sufficiency question. It's about the value of x minus 2 to the power 7. As before, you are given two statements in order to answer the question. Let me point out once again, the actual value of x minus 2 to the power 7 is irrelevant. And in this particular example, each statement alone gives a value for x, so that x minus 2 to the power 7 becomes computable. So here, each statement alone is sufficient to give an answer. The correct choice is D. The second example is a problem-solving question. If a minus b equals 1, then what is the value of a to the power 3 minus b to the power 3? As before, you are given 5 possible choices. Now there are two possibilities. You can either remember that there is a binomial formula for the a to the power 3 minus b to the power 3, which presents it as a product of a minus b and a squared plus ab plus b squared. In this case, you know that a minus b equals 1, and you conclude that a to the power 3 minus b to the power 3 equals a squared plus ab plus b squared. So the correct answer is E. Alternatively, you can plug in example values where you should avoid plugging in the very easy numbers 0 and 1. If you plug in, for example, a equals 3 and b equals 2, then you will find that the condition that a minus b equals 1 is satisfied, so this choice is fine, and then the expression a to the power 3 minus b to the power 3 equals 19, as does the expression in the choice E. We conclude that E is the correct answer.